Greetings. Hello and welcome back. Today we are heading into a section which is really changing. And as a geographer, this is an area that requires up-to-date research. And again, it's kind of unlike the other social sciences too, because it is so tied to current events and the political situation in the world. And I'm talking about the geography of natural resources. So turn to chapter 12. And this section here will involve more data than usual, hence a larger lecture, a longer lecture. And it probably could be broken up into two chapters. Your authors did not do that, and maybe I'll do that next time into renewable and non-renewable energy. But nevertheless, um, again, that's not how um, that shakes itself out here at this particular time. But it'll be fine. Everything will be fine. We will learn regardless of the layout of it. Some of the major heads-up terms and objectives here. We want to identify major sources of renewable and non-renewable energy, formulate an opinion on domestic energy policy, and understand forest and wetlands usage. Some of the major heads-up terms here: non-renewable resources. These are what can run out, or they just generate too slowly. Renewable resources, resources that nature replenishes. Prove resources. These are resources that we know we have, right? We know where they are. We know that we have them. Nuclear fission. This creates electricity. Nuclear fusion. This creates things like bombs. Oil shale. Comes from a sedimentary rock that contains shale oil, tar sand, a mixture of organic liquids that form asphalt. The estuarine zone, see, I have that up there. That's where salt and fresh water intersect with one another. And fracking, fracking or hydraulic fracturing. This is a kind of where horizontal drilling and in these tight oil bearing shale formations. The well gets drilled vertically until it reaches these oil bearing shale formations. Then the shaft turns and drills laterally, and under high pressure chemically treated water and sand are injected underground to break open these tight oil bearing rock formations. So the sand therefore serves to hold open the fractures so the oil can travel to the well. Let's take a look here at renewable and non-renewable energy here right off the bat. And renewable energy, get my bearings straight here. Renewable energy, you see some notes there, is where material gets replaced by natural processes used over time, and it gets replenished. Non-renewable, finite amounts, or they just generate too slowly to be counted on. Fossil fuels, nuclear fuels, lack of alternatives. Figure 12.3 on page 336 gives you a visual breakdown of that. Prove reserves, quantities that can be extracted from known reserves. Oil. Oil is adaptable. You can use it for power vehicles. Major output for refineries. It's efficient to transport. Uh, you know, pipeline, you can take it through pipeline, oil tankers at a fairly low cost. Figure 12.5 over on page, it's 337 now. What figure 12.5? Figure 12.5 over on page 338. There we go. 338 gives you the sources of energy in the United States from the 1770s right up through this up to the middle of this past century. Figure 12.7 or 12.6 gives you the leading producers of oil. Figures 12.7 and 12.8 where the major international crude oil shipments have been, and then the regional share of proved oil reserves in billions of barrels around the globe. Your major producers: Russia, Saudi Arabia, North Africa, Venezuela, not necessarily allies of the United States, or the, folks that we can be counted on. And then there's Alberta, Canada, right? Alberta, Canada, which the Keystone Pipeline was coming out of. We're still getting oil from Canada. So U.S. Imported about 60% of their oil that it consumed from those nations, right? More is found in the Gulf of Mexico and American waters. Up until recently, we were actually unable to extract that oil. It was in our waters, but the Chinese were actually there doing it. So yes, I mentioned this in my face-to-face classes, and I get these puzzled looks that doesn't make sense, and it doesn't, right? A lot of stuff does not make sense in politics. Take a look at the talk about fracking a little bit later. Coal. Let's look at coal. Coal is a non-renewable resource, although reserves are said to be in the centuries. 250 billion tons of it here in the United States. Figure 12.9 over on page 342 has a inset map there of regional shares of proved coal reserves as of 2014, 2015 on page 342. Coal energy supply has increased in the United States. Well, it did increase up until the mid 2000s. It increased since since the mid 2000s. That dropped. That the demand for it dropped, and so did the production. But coal is very useful, right? It's necessary for electric power generation. You need to make coke for steel production, heating homes. Okay, very valuable in that regard. Its value is based on the rank and grade and its accessibility. Much of the mining, though, is dangerous and expensive. You have shaft mining, you have surface destruction with it, alleged lake contamination, and it's costly to transport. Usually, though, there's not a long export route. Especially if you're near coal hubs, like we are with Pittsburgh. Take a look at natural gas. And natural gas is considered the perfect energy source. Methane, the least impact on the environment, about 25% of your global energy production. It's used for industrial and residential heating, flows cheaply by pipeline, But you have to watch it. The methane and the air mixture can be explosive, right? But it is protected by pipeline. Russia and the Middle East contain most of the proved reserves, about 60 to 70% of that. We do have potential reserves in Alaska. Figures 12, 11, and 12 over on page 345 gives you the major worldwide trade flows of natural gas and approved natural gas reserves. Enter fracking. Enter fracking up until the Trump administration. I didn't really include it in the lectures, but recently have had to do that. And you have some readings. We'll talk about the end of the lecture that are going to be solely focused on fracking, which I'm going to be looking for to be included in the discussions. Some of you folks are not doing that, and I therefore know who's looking at the lectures, right? So much depends on listening to the lectures, right? The hub of the wheel. Fracking. Vertically drilled. Talked about that at the start. Vertically drilled or hydraulic fracturing. Vertically and laterally, drilled. It's chemically treated water and sand, and applied with great pressure, right, to crack tight rock formations. The sand acts as a wedge to allow oil to get to the well, and as a result, the economic reserves of petroleum. So it has resurrected ghost towns into boom towns, but the science of fracking is far from settled. I want to talk also about, and again, and this gets into the politics of the situation. The science has been hardly settled, but what's happened here is, kind of a modern miracle of, these North American boom towns. And fracking is, as I say here, America's miracle of newfound energy independence, a reality almost inconceivable just a decade ago. Now, President Biden has already made executive orders, looking to shut down the Keystone oil pipeline, which is connected to fracking. One of your readings will be talking about not Mr. Biden's executive order, but the connection of fracking and the Keystone pipeline. Again, a reality inconceivable just a decade ago, and that has produced oil and gas booms in the United States that has helped reboot the economy while causing oil and gas prices to plummet for the in the present era. Oil, shale, and tar sands. Oil shale is a fine grained rock containing carrigan, and the carrigan is it's an organic material. It's a waxy tar-like substance. It gets crushed and it gets heated to about 900 degrees, and then it gets decomposed, becoming liquid oil shale. Figure 1213 over on page 346 gives you where the oil shale deposits are, and you can see a lot of those, several of those, right here in the United States. In fact, there's enough oil here. Looking at the fills, there's enough oil in the United States provided oil shales to supply Americans with enough oil for another century. The tar sands. Tar sands. This is bitumen saturated, and bitumen saturated. It's a mixture of organic liquids that are highly viscous and or sticky, and you know it's black, again very sticky and entirely soluble. Considered to be larger than your typical oil reserves. There's several tons of it here, here in North America. Most is in Alberta, and that makes up for about 10% of Canada's oil demand. Figure 1214 over on page 12, or over on page 347. It gives you a photograph of that being extracted, and it gives you an inset map of Alberta. Figure 1215 at the bottom of the page, leading producers and consumers of nuclear energy as of 2014. Also, Venezuela, Russia have large quantities of this. Utah, just a wealth of resources. Thing is, too, carrying it is both expensive and, again, there are environmental questions. Nuclear power. Nuclear power has two major ways of getting generated. Nuclear fission and nuclear fusion. The fission splits the atomic nucleus of uranium-235, which converts to heat, which creates steam, hence derives turbines, creates electricity. Fusion is where the atoms get split and it forms hydrogen. And fusion is what makes the sun burn, and it is what is used to make the bomb, right? But it is not controlled. Figure 1216 on page 348 gives you where the operating nuclear power plants are in the United States as of circa 2016. Now, since 1979, only two reactors have been developed. They're both in Tennessee. Tennessee Watts bar units 1 and 2. There have been applications to have some nuclear reactors built, but not since 1979, with some of the alleged, well, not alleged, you had some meltdowns in the late 70s, and so we've been really reticent about building more of those. I want to switch now to renewable resources and clean air type alternatives, and looking at biomass fuel. Biomass fuel is plants, animals, and wood, where they get burned in the heat source or converted into liquids. Wood is a key source in the developing world. They use it for cooking, heating, lighting, and waste. Animal and human waste gets fermented to methane gas. Biomass, though, supplies an insignificant amount of energy in the developing world. Then there's hydropower. All right, hydropower, falling water, dams, water wheels, and these are all what I'm talking about now, these clean sources of energy. Hydropower is generally used in the region where it is produced, and it's a major supplier of electricity in many developed and developing countries. Solar energy. Solar energy is the origin of all of the other sources. Problem here is, though, capture of it can be the salvation of everything else. But the problem is, how do you collect it? And then once you collect it, how do you store it? Wind power, the advantages and disadvantages of it. The advantages of wind, it turns turbines all without fuel. They could be built quickly. They don't pollute and they don't deplete natural resources. The disadvantages of it, though, they're unreliable, right? They're not continuous. They need a backup system since it's not easily stored. And they're most plentiful in remote areas, which we know here in Somerset County. The landscape is dotted with them. Um, but they're also far from existing power grids. Aesthetic impact, migrating birdies, all right, tend to run into them. And also, it takes thousands of these to get the same amount of electricity as one nuclear power plant. Figure 1222 has I think it's just a picture of, yes, looks like may have been taken right here in Somerset County. No, it isn't. It's a wind farm in California. But, again, we have some communities that have been against the presence of these wind farms because they're not, they're not cosmetically, they don't look good. And again, they can hurt bird life. Get into wetlands and finish up here. Wetlands and forests. Wetlands are basically vegetated. I don't know if I included this for you guys. Vegetated land surfaces they're periodically or permanently covered by or saturated with standing water. Now, not to riff on this too long, but in light of that definition, it's been argued that there's been mischief conducted by certain groups and opens up a lot of activity for government bureaucrats. And some folks wonder if there should be a limit on what constitutes a wetland. Grassy marshes, wooded swamps that range from prairie potholes to the Everglades. And depending on what state you're in, that here in the United States, that varies. Okay. Two major categories, inland and coastal waterways. Inland and coastal waterways. And most of the United States are inland, which consists of fresh water, bogs and marshes, swamps and floodplains. Then you have your estuarine zone, that's where fresh and salt water meet. And there are several functions to a wetland. They improve water quality by trapping debris and pollutants that water brings downstream. They provide habitat and food for many plants and animals. They're a breeding and nesting ground for many types of birds, and they absorb floodwaters, stabilizing shorelines. They've also been looked at as menaces. I like that word. They foster mosquitoes and therefore get dug up for commercial development. They're sometimes converted to cropland. They become garbage dumps. They get polluted, and then as a result of that, shorelines get bulldozed. Under the Nixon administration back in 1972, the Clean Water Act was written, and basically for federal protection, right? Can't fill wetlands without permits. Lastly, forests. Forests. 1/3 of the world's land area consists of forests. The ecological purposes, soil and watershed conservation, provision for habitat for wildlife and recreation, global recycling of water, carbon and oxygen. Tropical rainforests extend across parts of Asia, Africa, and Latin America. But there are benefits to deforestation. The benefits to deforestation, they relieve high population densities. They give farmers and ranchers a place to develop livelihood. They allow natural resources to get tapped. It has assisted Brazil, right? Brazil's the most well known for a rainforest. They've assisted Brazil in repaying their national debt. Forests in Western Europe and the United States were cleared long ago, so the so called exploitation has led to great wealth. Some of the disadvantages: maintains oxygen. They maintain oxygen and the carbon balance of the earth. Burning forests allows carbon dioxide back into the atmosphere, which can contribute to the warming of the atmosphere. Fire contributes to the depletion of the ozone layer, causing the extinction of thousands of plant and animal species, right, by deforestation that do not exist outside of Brazil. And then tropical rainforests contain important staple crops, rice, corn, squash, banana, pineapple, and sugar cane. Okay. Now, commercial forests can be considered a renewable resource. Commercial forests can be considered a renewable resource if sustainable yield techniques are practiced. Two techniques. One is clear cutting. All trees are removed from a particular area at once. The site is left to replenish itself naturally, or, get replanted with fast growing seedlings. Take my T out of there earlier, spelled that wrong. Second type of technique is selective cutting. And this gets practiced in mixed forests. The older trees are often cut for the sake of younger trees, and what has been cut will also regenerate. Clear cutting is seen as the most economic route. Okay. So you have your graphic organizer that I provided, give you a nice chart there of nice chart, renewable resources, and you can look at nice breakdown. Let's take a look at what's up ahead. Your readings will be the pros of fracking, and how fracking killed Keystone and is actually saving the climate. Okay, Wednesday, you have your kind of a comprehension exercise. I call it sentence starters. You will go through the lecture model and even the text if you want to see some vocabulary headings, and start the sentence based off of the context. Thursday will be the labs. And I'm thinking back here, the labs, you're basically going to be looking at forested areas, where the most forests are, where they've been cut down. Okay. And then Friday, you have your posts, your response posts by Sunday. And then we'll quiz on Monday. We'll begin chapter 13, the human impact on the environment. Okay. Any questions, comments, don't hesitate to get a hold of me. And I'll see you next time. You guys have a great week and do well. See you next time.